Hello class, we're about to start section 9.3, the quadratic formula. We distribute when we multiply a monomial by a binomial. We may also distribute when we divide a binomial by a monomial, which we would do here. What we would have to do here is we would take 15x divided by 3 plus 12 divided by 3. Now we know 15 divided by 3 is 5, and we bring down our x. Plus 12 divided by 3 is 4. So our final answer here is 5x plus 4. Okay, now another way to approach this division is to factor the numerator, then reduce the fraction. Now we have to ask ourselves, what is the highest factor that 15 and 12 have in common? The highest factor of 15 and 12 is 3. So we factor out a 3. And we will have left in our parentheses 5x plus 4. And that's divided by 3. Now, these 3 simplify out to 1. And that leaves in our numerator 5x plus 4. And our denominator is 1. And we know anything divided by 1 is itself. So our final answer here is 5x plus 4, the same answer we got in the first example. Now we go down here to these examples here so we can apply this principle. First thing, I think it would be better if we do the first example's way. Because if you simplify here, you're guaranteed to be done with this problem. So let's do this with A. We will have 8/10 plus 6 square root 7 all over 10. Now we know 8 and 10 has 2 in common. So that will give us 4/5 plus, now 6 and 10 has 2 in common. So we would divide both by 2, and our numerator would be 3 square root 7, and our denominator would be 5. And since this has the same denominator, we could just combine it. We have 4 plus 3 square root 7 all over 5. Now we go to B. We could do the same thing here. We would have 35 over 45 plus 15 square root 3 all over 45. Now, 35 and 45, we know they both have 5 in common. So we would divide the numerator and denominator by 5, and that will leave us 7/9. Plus, now 15 and 45, they both have 5 in common. Well, actually, they have 15 in common. We could divide the numerator and denominator by 15. That would leave us the square root of 3 for our numerator, and our denominator would be 3. Now, if you look here, these do not have the same denominator, so we would leave this as is. So your final answer here would be 7/9 plus the square root of 3 over 3. Now we scroll down here to C. We do the same thing here. We will have 14 over 8 minus the square root of 12 over 8. Now 14 divided by 8, we know they only have 2 in common, so this will give us 7/4 minus. Now we have to look here at this square root of 12. This square root of 12, we do have a perfect square in 12, which is 4. So we will break that up to the square root of 4 times the square root of 3 all over 8. Now, we know that the square root of 4 is 2. Square root 3 all over 8. Now, 2 and 8 has 2 in common. So what we will have here is, we will have 7/4 minus, we'll divide both of these by 2, and we will have square root of 3 all over 4. Now, let me go back here and put in my equal signs. Now we have the same denominator here. So our denominator would be 4, and our numerator would be 7 minus the square root of 3. And that is our final answer. Now we go here to D. Again, we can separate this. We will have 6/12 minus the square root of 18 all over 12. Now we know 6 and 12, the greatest common factor they have is 6. We could divide both of these by 6, and that would leave us 1/2. Minus, our denominator would stay 12 here, but our numerator, with the square root of 18, the highest perfect square we have in 18 is 9. So we'll take the square root of 9 times the square root of 2. Now we know the square root of 9 is 3. So we add 3 square root of 2 all over 12. Now, with 3 and 12, they have 3 in common. So this would be 1/2 minus, this would be the square root of 2, and 3 into 12 goes 4 times. So this is our final answer since we do not have the same denominator. Now we scroll down to the next page. We have objective 1. Solve quadratic equations using the quadratic formula. Now we have talked about 2 types of quadratic equations that we can solve. Now, this is just a review from the last section. But here we can factor. Now we went over factoring plenty of times. So we know here that our parentheses will be x minus 2 and x minus 5. Now we would set both of these parentheses equal to 0. And we would solve. We would add 2 to both sides here, and we had x is 2. We would add 5 to both sides here, and we have x is 5. So our final answer here, if we substitute in 2 and 5, both of them work. So our final answer you could write as x equals 2, 5. Now that would take care of this if we were using factoring. Now, if we were using the radical method that we learned, or the square root method that we learned, we would take the square root of both sides. Now we know this square root and this square would simplify out and leave us x plus 3. Now on the other side, this square root of 8, we will be left with positive and negative of the square root of 8. Now, we could take that square root of 8, and we could take out the highest perfect square in 8, which is 4. So it would be square root of 4 times the square root of 2. So we have x plus 3 is equal to plus or minus 2 times the square root of 2. Now we will subtract 3 on both sides. And our final answer would be x is equal to negative 3 plus or minus 2 square root 2. Now, of course, I know that we use MyMathLab, so it is possible that this answer will not be acceptable. They may want you to write it out in expanded form. Now, this is expanded form. You have x is equal to negative 3 plus 2 square root of 2, comma, negative 3 minus 2 square root of 2. Both of these answers are correct, but depending on MyMathLab, it may accept this version or this version here. Now, we scroll down here. It says, does that cover all possible quadratic equations? Think about x squared plus 7x plus 4 equals 0. Can you factor? No, we cannot factor. Can you get the form something squared equals a number? Now, we know this would not give us a perfect square factored out. So no, we cannot use this here. It says, now we will learn a third method for solving quadratic equations. Fail-safe and works every time. It is not always the most efficient method. Stay tuned for more on that, but it is guaranteed to work on all quadratic equations. Now, what that is saying is that if the quadratic equation can be solved, this equation here you could use to solve it. Now, first of all, we need to look at the standard form of a quadratic equation. This is the standard form. Now, when using this equation here, your lead coefficient cannot be 0. It could be any other number but 0. So the coefficient in front of the variable squared is our a, the coefficient in front of x is our b, and then our constant is c. And the equation must equal 0 in order to use this equation here. Okay, now, one other thing I want you to notice. I want you to notice here that this division bar or fraction bar covers everything in the numerator. That will become important later. So everything in this numerator is divided by 2 times a. Now we have example 2 here. It says solve x squared plus 2x minus 24 equals 0 by using the quadratic formula and then by factoring. Compare your results. Okay, now first thing, we have x squared plus 2x minus 24 equals 0. So off to the side here, we should list out what our a, b, and c is. We can write it here. Now our a is the coefficient of the variable squared, which is 1. Our b is the coefficient of the variable to the first power, which is 2. And our c is this constant here, which would be negative 24, because you must carry the sign also. Now you notice this equation has to equal 0 in order for you to do this. So now we look here, we use our quadratic equation. It'll be negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So now we go through and substitute. We add negative, and then we'll put in what b is. Plus or minus the square root of b is still 2, and that's squared, minus 4 times a is 1, and c is negative 24. Okay, I have to scroll down for more space here. Okay, now that's all over 2 times, and we know a is 1. Okay, so now we have negative 2 plus or minus the square root of 2 squared is 4, and then we have minus 4 times 1, which we know is minus 4, times a minus 24, which will give us a positive 96. And that's all over 2 times 1, which is 2. So we have x is equal to, this will be negative 2 plus or minus the square root of 100, all over 2. And we have to scroll down a little bit more here. Now we have x is equal to negative 2 plus or minus, we know the square root of 100 is 10, all divided by 2. Now we have to go through and find both of our answers here. And this is how we would do it. You would take first, you would have x is equal to negative 2 plus 10 all over 2, comma, x is equal to, we would have negative 2 minus 10 all over 2. Now negative 2 plus 10 we know is 8. So this will give us 8 over 2, which we know is 4, comma. Now we go here. We have negative 2 minus 10, which we know is negative 12, divided by 2. And negative 12 divided by 2 will give us negative 6. So our final answer here is 4 and negative 6. And if you put this back into the equation, 4 and negative 6 will actually work. Okay, now for the factoring side, we have x squared plus 2x minus 24 equals 0. Now we know we have our a, b, and c here. Let's go back over factoring this. Okay, first we'll do our a times c. 1 times negative 24, we know it's negative 24. And we write out the factors of 24, which is 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now we also must find two numbers added together, well, multiplied together, that will give you negative 24, but added together will give you positive 2. And since your b is positive, we know that that means that the lower numbers will be negative. And we know we will use negative 4 and 6.